All right. It's your man, Jimmy Chan. Let's start with the answer key for LabWork 10. So this is where we're going to be talking about radicals. And obviously you're going to be first time seeing things in here, which is called the wedge. That's what I would call the wedge. And that tells you a little bit something. So that wedge tells you that I want 4 of a kind, okay, or groups of 4, okay. So with that being said, the first thing we need to do is take the 256, the x to the 12th, and y to the 8th, and break those down. So if I take the 256 and break it down, when I say break it down, I mean to primes, and to do the primes would be the factor tree. So 2 goes into that 128. 2 is done. 128 goes in. 2 goes into 128 64 times. 2 is done. 2 is done. 64. 2 goes into 64 32 times. 2 goes into 32 16 times. 2 goes into 16 8 times. 2 goes into 8 4 times. And 2 goes into 4 twice. So there's 1, 2, 3, 4, 5, 6, 7, 8. So this is just basically telling you that 2 to the 8th power is equal to 256. Okay? So with that being said, I'm going to go ahead and take this out of there and delete that. So I'm going to write this down here. 2 to the 8th is equal to 256. All right. So that means I'm going to write this 8 times. 2, 2, 2, 2 times 2, 2, 2, 2. X to the 12th. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And the Y's. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So if I had the choice, I would go, okay, let's bring this down. All right. Now, that negative in front is going to stay there. But let me draw this radical first. So essentially that's why I have with the 4 in the wedge and that negative sign right in front still. Okay. So what I'm looking for is groups of 4 or 4 of a kind, right? Groups of 4. Okay. So if I look here, there's a group of 4 2s, and there's another group of 4 2s, right? So that's going to come out of the house as in, I'll put that negative back in, as in 2 times 2. That's your 2 groups of 2. Now let's look at your x's. I got 1 group, 2 group, 3 groups of 4 of x's. So that's going to come out as 2, 3 groups. And then the y's, there's 1, 2 groups. So that's going to come out as y times y. So if you notice that there is even amount of groups, right? Meaning there's nothing left over. All the groups are groups of 4 of either the 2's, x's, or y's, and there's nothing left inside the house. So in other words, that house I do not need anymore. So with that being said, this would be my answer right here, which is negative 4 x to the 3rd y squared. Okay, with that being said, that is answer B. So I would tell you to always break down what's inside the radical and look at the index to know how many in each group needs to be. Okay? So that is number 1. So let's look at number 2. So look at this right here. This right here says that this is going to be, the groups are going to be 3. Okay, so 3 of a kind, or groups of 3. Okay. All right. With that being said, so let's break everything down. So this is negative 27 is going to be a negative 3 times negative 3 times negative 3. Okay. X, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15, 18, 21, 24, 27, and 30. And then I have the Y's. 1, 2, 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, and 36. Okay, now notice that because I had a index of 4 here, right, that I lined these up as 4 columns, where this one here has an index of 3, so everything is lined up in 3 columns. Okay, so again, let me redraw this radical here. With the 3 in the wedge, which is my index. All right, so let's look at how many groups of negative 3s do I have. I have 1 group, right? All right, so that is saying I have a group of negative 3s. Let's look at the x's. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's going to give me x to the 10th. How many groups of y's do I have? Let's use that one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have y to the 12th. So again, no stragglers. Everybody's in the group. So everybody gets to go outside of the house to play. So therefore my answer is negative 3, x to the 10th, y to the 12th. Okay? And that's going to be choice B. There we go. All right? So that's number 2. All right, on to number 3. Now this one, you got several ways of doing this. So when I divide 2 radicals and they have the same exact index, that means I could put it under 1 radical. So I could actually say that this is equal to 320x to the 13th over 5x. Now, you can do it 2 ways. You can either reduce everything first and then deal with it, or you could deal with each individual radical here right, by itself, and then reduce the whole thing. It doesn't really matter. So, and obviously you're going to ask me, what do I think? So here is what I think. I'm going to tell you that probably a good thing to do is, if you notice that the 320, the 5 can go into 320, so maybe go ahead and say, okay, so 320 divided by 5 gives me 64. So in actuality, I can reduce this now to be 64x to the 12th. Okay. And again, my index is still a 3. Right? So again, my index is a 3. So I'm looking for groups of 3. Okay? So let's break down to 64. 2 goes into 64 32 times. 2 goes into 32 16 times. 2 goes into 16 8 times. 2 goes into 8 4 times. And 2 goes into 4 twice. So I got 1, 2, 3, 4, 5, 6. So 2 to the 6 would equal to 64. In other words, 2 times 2 times 2 times 2 times 2 times 2 is equal to 64. Okay? So let me go ahead and erase this. So that's the advantage of seeing, watching the video here. So 2 to the 6 is equal to 64. Okay. So let's go ahead and let me go ahead and copy this, or at least duplicate it. Bring it over here. So that means I want to take 64 and break it down to 2 times 2 times 2 times 2 times 2 times 2. And x is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? All right. So let's see here. There's a way. 3 there. Okay. So let's look at the 3s. Look at the 2s. So groups 3, and there it is, my 2 pairs. So 2 squared. 1, 2, 3, 4 groups. Okay. Again, nobody left over. So this is going to be a 4x to the 4th. Alright? And that is going to be choice C. Now, do you have to do it exactly this way? And the answer is no, you do not. Because you could look at the 64 x to the 12th. So you may need to break down the 64 so you know what you're looking for. But I will also say that with the x's, with the variables, it's easier, right? So if I'm looking for groups of 3, how many groups of 3 can you get with 12 x's? And you can figure that part out, that it would be 4 groups of x's, and that's why you got the x to the 4th. Okay? All right. So that's number 3. On to number 4. Well, if you notice, number 4 is a little bit different, right? Where number 3, we go, well, look, I know that 5 goes into 320, so I know that, that goes in. So let me put that in the calculator and get 64. And I know that x to the 13th divided by x is, we're going to lose one of the x's. So I got 12 x's left on top. And that's why you got x to the 12th. However, on the next problem, it doesn't work that way, right? So the problem is that there's nothing that goes into 25 nor 32, and there's no x's or y's on the bottom, all right? But it's still under one radical. And if you notice that the index here, there's no numbers there. When there's no number there, it means that the index is a 2, okay? So with that being said, same thing as what I said here on the previous one, that when I have 2 radicals with the same index, I can put it under one radical, okay? So this is exactly the opposite way. Because I have one radical that's over the whole fraction, I can actually split up those radicals, okay? So let's go ahead and do that. So this one is 32x squared y over just square root of 25, okay? So when the index is a 2, we call those square roots, okay? So the index is 2, so we're really looking for groups of 2 or pairs, okay? All right, so let's break down 32. Well, 32 is going to be, and sometimes you're not going to have the space to do it, so 32 is 2 times 2. Actually, I do have the space here, actually. Let's use it. So I got 2 times 2 times 2 times 2 times 2, right? Because 32 is going to be 2 to the 5th, okay? And then I got x times x and a y. And that's going to be all over. And 25, lucky for you, is going to be a 5 times 5. Okay, so I can break those down as well. So let's look at the pairs. Okay, so I have a pair with a 2 left over. Okay, you see the 2 left over here. Okay, so this is how I would do this. Okay, so what I have is I have the 2 squared on the inside, and then the 2 that I circled on the outside, because that doesn't have a, oops, sorry, undo. Let's try this again. I got 2 squared on the outside because that they are pairs, and then the 2 that's all alone that doesn't have a pair, so they can't come out to play, so it stays inside. Okay, so let's look at the x's. The x's has a pair with nothing left over, so that's going to be just an x. Okay, just one group of x. Now let's look at the y. Oh, the problem with the y is it doesn't have a pair. So that means that y doesn't have anybody to play with either. So that's got to stay inside as well. Okay, so with that being said, my answer is going to be 4x times the square root of 2y. Okay, so if it can't be in the group, then it has to stay inside the house. And with that being said, number 4 is going to be choice D. There you go. All right, on to number 5. All right, number 5. So dividing, multiplying, same idea. I can actually make this under one radical. Which is going to be a 32 times a 50. Now you might ask me, why didn't I just multiply those two? And here's the reason why. I believe that I can break down the 32 and break down the 50 individually. In fact, I would do it this way, just so you guys can see it. Let's change that to blue and change that to red. Okay, so if that's the case, when I break down these numbers with prime factorization, the 32 is going to be a 2 times 2 times 2 times 2 times 2. The 50 is going to be a 5 times 5 times a 2. Okay, now if I was to list these out, what I really have here is, actually, let me do it this way here. So what I can really do is take this 2 right here and move it with this 2. So let me do it this way. I got it. Move this aside. There's a leftover 2 from here, and this is a leftover 2 from there, and these two are multiplying. Okay, so when I look at this, so let me put this all underneath the radical again. Okay, so what I really have here is this. So let me look at the pairs. Here's a pair, here's a pair. With the blue, here's a pair, but then combined, I have another pair there. So again, there's nobody left alone, right? They're from different groups, it's okay. There's still a pair of 2s that can come out to play. So I have the 2 squared from the red ones, right? I have the 2 from this group here that was mixed, and then I have a group of 5 that come out as well. Okay, and with that being said, that's going to equal to 8 times 5, which is equal to 40, which that will be choice A. There we go. All right, on to number 6. All right, on to number 6. Same idea, except this has a different index, right? The index is still 3, and they're both the same index, so I can actually multiply them together. So I have 10 times 49 times x squared, but the index is a 3, so I'm looking for groups of 3. So let me go ahead and write down index is a 3, so we're looking for groups of 3. Okay, so let's break this down. 10 is 2 times 5 49 is 7 times 7. And x squared is x times x. All right. So you should be saying, Houston, we have a problem. But what's the problem? That this thing won't make a straight line. So what's the problem here? The problem is that I have no groups of 3, right? 2 times 5 is 10. 7 times 7 is 49. And x times x is x squared. But I want groups of 3, and there's no groups of 3. Okay, if that's the case, I forgot the 3 here. If that's the case, then this is just going to be as is. The 10 times 49 is going to be 490. And the x squared. Let me write the 490 a little better. Still don't like that. There we go. So 490x squared, and it's a cube root of that. And this is number 6, so that's going to be choice B. All right. There you go. Since there's no groups of 3, I can't do anything else. Now, 7 is adding, subtracting. So adding, subtracting radicals. In order to add or subtract radicals, we have to have like radicals. And what the heck are like radicals? Radicals that have the same index and the same, oh, I need more space than this for that word. Radicand. And the radicand is what's inside the house. Okay? So this is the radicand here. So this radicand will be the 32 or the 121 or the 98 or the 100. Okay? That's the radicand. Oops. All right? So that is what a radicand is. Okay? So if it's not the same radicand, then you can't add them. However, it means I can break these down first. So the first thing I should do is to I should call this probably simplify. Each radical. And 2, add and subtract like radicals. There we go. All right. So let's take a look. Okay. So 100. Let's break down 100. And these are all square roots because there's no index in them. So what's 100 going to be? 100 is going to be 2 times 2 times 5 times 5. If you don't believe me, do the factor tree and you'll see it. Plus 98 is going to be 2 times 7 times 7. Plus 121 is going to be 11 times 11. Plus 2 times 2 times 2 times 2 times 2. All right. we go. All right. So, again, we're looking for pairs, right? If we're looking for pairs, then the square root 100 is going to have a pair of 2's and a pair of 5's. This one's going to have a pair of 7 with a 2 left over, plus the square root 11 is just going to be, square root 121, which is a pair of 11s, so the 11 comes out, plus, how many pairs are here? 1, 2, so that's going to be 4, or 2 squared, and you know what, let's do that. 2 squared, and left with a 2 on the inside, okay? So really I have 10 plus 7 square root of 2 plus 11 plus 4. Square root of 2. Close enough. All right. So I have like terms here. So when I look at like terms, I got the 10 and the 11, which gives me the 21. And then I got the 7 square root of 2 plus the 4 square root of 2. So it's kind of like saying taking 7x plus 4x, right? That's going to give me an 11. Square root of 2. Okay, so that would be my answer there, and this is what, number 7. So number 7 is going to give me choice A. And there we go. All right, on to number 8. Same thing, adding and subtracting. So I need like radicals, but first I'm going to break everything down, okay? So there's some things that are already on the outside. Great. So let's deal with that. And we notice that the index are both the same, okay? So let's go ahead and break these down. So I have the 9. So this is going to be x times x times x. And now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. So I got to fix this radical here. There we go. There we go. And then I got the minus 2xy. And then I got to do this one. So let's see if I can match the same one. So the 8 is going to be a 2 times 2 times 2. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, and 1 left. Okay? So, again, based on the index, look at what I just did. I put them in 3 columns, right? So, on the first one, I got the 9, right? So let's look at what I got. I got x, a group of x. So the x comes out. No more x's left. On the y, I have 1, 2, 3, 4 with 1 left over. Right? So that means I have a y to the 4th with 1 left over on the inside. Okay, minus 2xy. All right, let's look at this again. I got a group of 2, so, oops. times 2. And then when I look at the y's, I got 1, 2, 3, with again a y left over. Okay? So that means I have y to the third with a y left. All right? So let's go ahead and simplify this first. So I have, let's focus on just the first one. The first one looks like just a 9xy to the fourth. Ooh, I keep on forgetting one thing here. You gotta keep on bringing down the index. Okay, minus 2xy, it's actually going to be 4 because of 2 times 2, x and y to the fourth as well, because there's y times a y cubed. And then with the y. So it looks like these are exactly like terms. So when I look at like terms here, now with variables, it had to be the same variables and same powers, right? So when you look at this, don't forget that yes, they're both x's, y to the fourth, and that does matter, and then the same index and the same radicand. Okay, so all three of those things, or four of those things, all have to be the same in order for these to add. So please be careful with that. Okay, so therefore my answer is going to be a 5xy to the fourth cube root of y. Okay, and that, as I turn the page, is choice D. Oops. And there we go. All right, so that's number 8. On to number 9. All right, so this one we're distributing. All right. So if I was to show this a better way, I would go ahead and duplicate this and bring it down. There you go. And what I would do is change that to red. All right, so when I multiply these two, do it. Now, I would tell you to do it as a distribution, and these are all square roots, so that part's nice. So I got the 3 times the square root of 147 plus square root of 3 times (21). Okay. Now, because they're the same index, I can put it under one radical, right? So if I put it under one radical, let's do that. And break it down as we go. So 3 times 147. 147, oops. 1 plus 4 plus 7 is 12, and that's divisible by 3, so 147 must be divisible by 3. It is. It's going to be 3 times 7 times 7 plus you got the 3, and the 21 is going to be 3 times 7. Okay. Nice. Okay. So again, I look for pairs because the index is a 2. So here on the first one, I got a pair of 3s and a pair of 7s. So the pair of 3 comes out, the pair of 7 comes out, nothing left. Plus, a pair of 3 comes out, and then what's left over is going to stay inside the house, which is just the 7. So my answer is going to be at 21 plus 3. I've always had issues with these drawing radicals here, especially in the app setting. So there's your answer right there, and that would be choice B. There we go. All right, so that's number 9. And on to number 10. Ooh, double distributing. So same thing, I would tell you to double distribute. Okay, so let me do this. I'm just going to start cheating here. So it's going to be this times this. Plus this times, this. Okay, so that's what I would tell you to do. All right, and I think it's easier to see anyways. All right, so what I'm going to have here is, when I do the first one, let me do it this way here. The first one is going to give me the 5 on the outside. Wow, that's a interesting 5. The 5 on the outside, and what's inside the house, and these are all square roots here, so we're okay. And it's going to be a 5x squared. And then the second one here, the 5 and the negative 7 are both outside the house, so that's going to give me a negative 35. And the only thing that's going to be inside the house is just going to be the x. All right. Then let me choose another color here. And let's go with green. And that's going to be plus 7. And that's going to be 5x. And then let's go with the fuchsia. So again, they're both outside the house, so that's going to be minus 49. Okay. So now, can we simplify any of the radicals? Yes, we can. The very first one. The very first one has a x squared. So that means there is a pair of x's there. So that can come out. So I got 5x square root of just a 5 left. Minus 35 there's no pairs of x's in there, so it's just going to have an x. Plus 7 and this is going to be 5x because there's no pair of 5 nor a pair of x, and minus the 49. Okay, so look at these. none of the radicals or the radicands are the same. There's no single numbers, so therefore none of these add together. So therefore we're going to have choice A. And there we go. Well, I hope that this helped. If you have any questions, let me know. All right. Talk to you later. See ya. Bye.